Lesson 5 is going to go over choosing a data display. This is going to be a little bit of a review, but we have to figure out when it's appropriate to use a bar graph versus a pie chart versus a histogram. So the first key vocabulary term that comes up is qualitative or categorical data. This is defined as data that consists of labels or non-numerical entries that can be separated into different categories. When using qualitative data, operations such as adding or finding the mean do not make sense. So for example, if we had all the data from giving out a survey to a bunch of students asking them, what is your favorite type of music? Different possibilities could be pop music or rap, classical, country, and so forth. These are different categories. It wouldn't make sense to say, all right, let's take the information and find the mean of it. Okay, so it would fall into the categorical or qualitative data set. Quantitative data is data that consists of numbers that represent counts or measurements. So this would be data that you get when you give out a survey asking how long does it take for you to complete your homework. All the data you're going to get back is a number. So you could easily find the mean of how long it takes 8th grade to complete homework versus the mean for how long it takes 6th grade to complete their homework and so forth. A misleading graph is a statistical graph that is not drawn appropriately. Believe it or not, this is sometimes done on purpose. It may occur when a creator wants to give viewers the impression that the results are better than they actually are. We'll talk about this a little bit later on in the notes. But for example 1, I would like you to classify the data, and you're going to tell whether the data is qualitative data, so that's going to be categories, or quantitative data, a numerical data set. I would like you to pause the video, fill in the 4 options, and then unpause as we go over the correct answers. For part A, prices of used cars at a dealership. Prices deal with money, and money is a numerical data set. So this is quantitative. For part B, I think this is the trickiest one. It says jersey numbers on a basketball team. So jersey numbers, although they are numbers, they're actually given as labels. It's labeling which player is which. So this would be qualitative. The lengths of songs played at a concert. Lengths is how long it's numerical data, so that would be quantitative. And think, can you take the mean of that data set? Would it make sense? And yes, it would. What's the average length of a song at a concert? For part D, it says zodiac signs of students in your class. Zodiac signs depend on what time of the year you were born, what month you were born in. Are you a Leo? Are you an Aries? And so forth. This is categories. So this is qualitative data. Example 2, we're going to be choosing and creating a data display. So the first thing, we're going to analyze the data and then create a display that best represents the data. We're going to explain our reasoning. So first, we have to see what they're talking about. And we have a survey of different students asking what their eye color is. These different colors that they fill out would be categories. So this is qualitative data because eye colors are categories, not numerical. So that being said, we wouldn't want to do a box and whisker plot. That is very numerical data oriented. We're not going to find the mean of the kids who have brown eyes. No. So for this, I think a circle graph would be lovely to use. So the first thing we'll do is let's draw a circle. And now we have to figure out how to fill this in. Some might look at this and say, oh, brown eyes, well, that's 63. So they're going to fill in 63% of the graph. All of this is brown eyes. That's not going to work. You're going to run out of room because the first thing you need to do is figure out how many students actually took this survey. That way of thinking the way I just explained would work if you had 100 students taking the survey, but we have more than that. When you add up 63, 37, 25, 10, 3, and 2, you end up with 140 students total. Okay, so now to figure out how much of this pie chart or circle graph, and I should say they want us to explain that too. So quantitative, because iColor is category, not numerical data. Therefore, we're going to use a pie chart, or AKA circle graph. Okay, so how much of the circle graph is going to be for brown-eyed students? The way you would figure this out is we have 63 brown-eyed students out of the total. Then we're going to take whatever that is and multiply it by 360 degrees. And the reason why is because the circle goes 360 degrees all the way around. So how many degrees is my angle going to be when I'm just taking in 63 out of the 140 students? And your answer is it would be 162 degree angle. So if this is the center of the circle, we would go from here, and if I draw a straight line, that's 180 degrees. I don't want that, so I need to be a little bit less than that, which would be about here. And we could label this as brown, and I would write the number 63 in there, which tells you that it's the number of students with that colored eye. The next is a blue colored eye. So let's get out of there. We need blue. To calculate the angle measurement for blue-eyed students, I would take 37 out of the 140 students, multiply it by 360 degrees. And it's approximately 95 degrees. So a 90-degree angle would be here, so I need to go a little bit more than that. So let's extend it right here, and we'll label this blue and write the number 37. Okay, the next we have hazel. So hazel, 25 out of 140 times 360 degrees. And when we do that, we end up getting a measurement of 64 degrees. So 64 degrees, we'll make it look about like that. And we'll write hazel and write 25. Okay, now for green, we would write 10 out of the 140 times 360 degrees, and you get an angle measurement close to 26 degrees. So that 26, we'll put it about like that. And this will be green. Now we only have a little bit left, but we'll be okay because the gray and amber only represent a really small population. So for gray, we have 3 out of 140 students times 360 degrees, is approximately 8-degree angle. So we'll take this and make it approximate like that. I can maybe even shade it in gray right outside gray and write the number 3 underneath. And the last one is amber, and that'll be this piece, amber, and there's only 2, but let's still calculate it. You would have 2 out of 140 students times 360 degrees to give you an approximate angle of 5 degrees. And that's how you would create a circle graph. For the second data set, it says analyze the data and create a display that best represents the data, explain your reasoning. So we have the speed of vehicles in miles per hour, and we have the speed on 2 different interstates, Interstate A and Interstate B. So the speed that a car is going, or a vehicle, is a numerical data. It's going to give you a number answer. So there's different data different data displays that you can choose from. We're going to choose to do a double box and whisker plot because numerical data fits well into those. You could also choose to do a stem and leaf plot, or even a line graph would work. But for our purposes, we will do, for this example, a double box and whisker plot because we have quantitative data. Now, this takes some manipulation with your data. I'm actually going to use Google Sheets because there's a lot of information given here. There's 20 data sets for each interstate. So I'm going to go over to Google Sheets, and you can just watch what I do here. And feel free to do this if you want on your homework, but right now you can just watch what happens. So what I have here is I have a picture of the data set from the notes, and I typed in all the numbers from Interstate A and all the numbers from Interstate B. And the reason I chose to show you how to do this if you want to do it in Sheets is because once all the information is typed in, I can take this and I can sort it so that it goes from least to greatest. And this allows me to figure out my information for a box and whisker plot pretty easily. You could have completely done this by writing it by hand as well. For Interstate A, we see that the minimum value is 59 and the maximum value is 82. To figure out the median, we have 20 numbers, so we're going to go up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number 68 and this number 68, since we have we have an even amount of data, we'll have two middle numbers. The middle of 68 and 68 happens to be 68. So that's perfect. We'll highlight those. And before I forget everything, let's go back to our notes and write these down. So we have 59, 68, and 82. So for Interstate A, 59, 68, and 82. So let's find the quartile 1 and 3. So quartile 1 will be in the middle of this first lower part of the numbers. So there's 10 numbers here. So let's go down to number 5. So 1, 2, 3, 4, 5. So on the other end, we can highlight this. But if we start over here at 68, we have 1, 2, 3, 4, 5, another middle number. So we actually have to find the average of 65 and 67, which in the middle of 65 and 67 is 66. So let's go to our notes and write 66 here. And to get our fifth number, we need to do the same, but with this half of the data set. So 1, 2, 3, 4, 5. That'll be 75. And looking ahead, if you go from the bottom, 1, 2, 3, 4, 5. The average of 75 and 75 is pretty easy. It is 75. So that's our data set for Interstate A. For Interstate B, we can put it in pink. Let's do the same thing using Google Sheets. So we have our information that I typed in, and I need to sort it so that it goes from least to greatest. The minimum value will be 65. The maximum value will be 84. We have 65 and 84. Let's find the median in quartile 1 and 3. So the median will be 72 and 73. We need to figure out that average. Well, in the middle of 72 and 73 is 72 and a half. Okay. And then to figure out quartile 1, it would be the average of 69 and 70, which would be 69 and a half. And finally, quartile 3 would be an average of 79 and 79, which is just going to be 79. Okay, so Google Sheets has played its role. We're done with that. Now, we have a smallest value of 59 and a greatest value of 84 to put on a number line. So let's draw a number line. And I'll start at 55. And I need to get all the way to 84. So I'm going to go up by, we'll go up by ones, but I'm going to label, every 5. So that'll be 60. It'll be 65. And I'm doing my best to keep them evenly spaced as much as possible. If you do it by hand, obviously it's not going to be perfect, but do your best. Okay, and that should be able to get all of the data on there. So for Interstate A, it would have your left whisker at 59. So let's put a dot right there. The box is going to go around 66 to 75. So 66 would be right here. 75 would be right here. That's your box. And your right whisker would go all the way to 82. Okay, now to get the median in there at 68, we would draw a line. All right. For Interstate B, we would start at 65 with the left whisker. The box goes around 69 and a half and 79. So 69 and a half is about right here. And we go all the way up to 79, which is about right there. And then the right whisker would go to 84. The median is 72 and a half, which is approximately right there. And when you compare the two, you can see that people are speeding faster on Interstate B than Interstate A. For example 3, we're going to analyze misleading graphs. So when you first look at this graph in part G, it has tuition, rooms, and board at all college universities. And it looks like from year 2007, 2008 to 2010, 2011, that the tuition for room and board and everything has just like increased drastically. Definitely the tuition is increasing because the bars are going up. But look at this is like on this bar graph, it has this background of these lines. It's like, oh, it's only going up 2 lines. And over here, it's going up 1, 2, 3, 4, 5 lines. So it looks like the tuition has more than doubled in price. That's not actually the case. Is the tuition going up? Yes, but it's not more than doubling. Okay, so what I did over here is I rewrote the data, and let's make a graph that is not misleading. So in Google Slides, you can just watch. I took that data and we're going to make a bar graph. Now, if you look, this bar graph, it begins at the y-axis at 0. And look, the tuition definitely is increasing, but it's not doubling or more than doubling by no means. And this graph or this bar graph shows the data more realistically than your notes do. Okay. Now over here, it has a graph that's a line graph for the mean hourly wage for employees at a fast food restaurant. And it looks like your salary in dollars per hour has skyrocketed from 2008 to 2013. You've been a loyal employee, and check it out. You started off making $8.90, and it looks like, holy cow, you are now making a whopping $9.06. Your salary has increased by 16 cents per hour over the last 6 years. That's actually not a big increase, but this line graph makes it look gigantic. So if we were going to take that data and display it, let's use Google Sheets to do that. So let's insert a chart, and they used a line graph. Oops. Oh, there we go. And here's your line chart. Look, it looks like a straight line. I suppose that, yeah, it doesn't even look like it has increased if we're going to make it on a non-misleading graph. So I just wanted you guys to see what the graphs would look like. Normally, you do not obviously have to use Google Sheets, but if you liked what you saw when I played with the data on Google Sheets, go for it. This concludes your notes for section 11.5. You are to do big ideas today, and that will conclude chapter 11. You will then have a review and followed by a quiz on Friday.